Hi everyone, myself Krish Raidurkar. Very warm welcome to all. And today we are going to discuss about very exciting topic, quantum and classical computer. How both are different between. We are looking at the differences between both of them. And nowadays the classical computer is too much used, but the hype of quantum computer is overhyped here in the future, and the quantum computer is considered as a future tech. Okay, so I will try to explain you in a such way like you can understand much clearly and more efficiently. So let's get started. Hey there. So let's start with understanding how the computer basically understand. So this is the basic foundation that we are going to cover here to understanding the difference between both of them, classical and quantum computer. So our foundation will be uh, bit, pivot, and qubit. This how they are both are different, like how pivot is different and how qubit and what is qubit and what the use cases of the both of them. So before understanding this particular concept about bit, pivot, and qubit, and this is the basic understanding, you have to basic understanding to understand much difference between both of them, and that create a basic of your understanding of quantum and classical models of the computer. So hope so you will understand. So let me start be understanding from there how the computer actually understand your language. So basically your language will be understood by the computer on encoded version, like encoded version. They encode your language in a binary digit, and the binary digit refer to 0 or 1. Okay, so computer is basically understand your language in 0 or 1. Okay, so it convert your particular language either in the form of 0 and 1, and they understand all the digit, understand in the form of 0 and 1. So these are called a binary digit, 0 and 1, and 0 refer to off and on, and 1 refer to on and off. So this is the basic language of the computer that really understand by the computer understand really your language in the 0 and 1. So hope so that's create a very foundation for you. And when we're looking toward to understanding bit refer to binary digit, 0, 1, and off. So bit is called 0 or 1. This 0 and 1 is considered a bit. So 1 and off. Okay, so easiest way to understand, like 1 refer to on, and uh, your off refer to 0. Okay, so you can easily memorize by this trick: 1 on, off 0. So reciprocal. So hope so that will explain you much better. And this is called a bit, which is 0 and 1. And let's come to the pivot refer to probabilistic bit. So bit, when I say the bit and probabilistic pivot, that probabilistic bit, if you toss a coin, then I think like the possibility of the getting 0 ahead or tail will be decided after when the coin stop. Okay, so when the coin stop, it actually differentiate the both of them, and you will decide the either head or tail. Okay, so the finding head and tail by probability is known as a pivot. So okay, pivot decide actually how the head and tail and coin of the toss. And let's come to the our foundation that really matter most in the quantum computer, and you need to understand it very well: qubit. What is qubit? So initially, after starting this qubit, you can understand this qubit as a look this qubit refer to quantum byte. And when you toss a coin, you have an opportunity in the first cases. When you when you actually toss a coin, then before stop the coin, you have a chances for either a 50% and a 50% of head and 50% of tail. Both probability will same. So in the case, in the first cases, their states will be both same. So okay, both the state are same. So in the qubit refer to superposition of the both 0 and 1 at the same time. Okay, so that is called qubit. That is called qubit. And when we're looking at qubit, we can understand this qubit as similar as a pbit, qubit, and all the stuff as a by condition. Okay, so I think you listen this clear carefully, because of that really help you to understand the quantum computer much better. Like first one is qubit. Qubit refer to something you can basically, I will give you a mathematical problem, so you can solve in 10 different way. Okay, so when you apply this 10 different way in the same time, like in a same time, okay, either trying one by one, so you can easily approach the question much faster as compared to trying one by one. So as simple, qubit refer to those things, like superposition of all the methods that you are going to try to solve this particular problem, mathematical problem, at the same time, is known as qubit. Okay, so that's all about the pivot and qubit, and hope so you will understand. Oh, so like come to the next topic, quantum and classical computer. So we're looking toward the difference between both of them, how both are different in a such way, like they are looking toward when we're looking toward both of them, like there is silly difference between both of them, like in the workflow, and when we compare, and in this particular we are going to compare both of them, like how the quantum and classical computer is different in scenarios, and what scenarios. So overall, let's come to the point. Overall, when we're looking toward the classical computer, like classical computer is invented by, I think, like Charles Babbage, and this is the father of the Charles Babbage. But when we're looking toward the classical computer, is really interesting. It is such as different in human, like it calculate fast, and when we comparing from the human, it is there have not too much storage capacity, and one of the thing, like it have on a processing fast, it process something, you can give them particular thing, it can process fast and give you an output as very fast way. So I think, like this is the way where human is just as lacking when we comparing from the classical computer. So when we're going to upside of the classical computer to, we are looking toward a quantum computer, and as early I say you about qubit is play in a very important role for understanding both of them, like okay. So before, for understanding this particular concept, we are going to cover in a uh, we are going to cover we take a simple example for understanding the particular topic, how the quantum and classical computer are different. For example, I give you a particular mathematical problem. So as you can see, I will give you a particular problem. For example, I give an equation to solve this particular equation. uh, when we look into a classical computer have an I think, like this problem gets solved by the 10 methods, 10 different method. You can apply 10 different method to crack this particular problem. Okay, so uh, classical computer play important role each here, like they try one method and check, is it right? No, yes, yes, no, yes, no, then it try all method one by one, and then after they try one, then after they predict the exact value, and they find the solution. But when we're looking toward the quantum computer, this case is just a different. I said you qubit. Qubit refer to something, you can say uh, both condition at the same time. That means all the 10 method you can apply at the same time, and you are not trying each method one by one. As a human being, you can try one method one by one. So in your method, I think, like you will try one by one instead of trying one by one all method. You can, in the quantum computer, that really try all step together and find the exact value. So that the difference between the classical and quantum computer is speed. I think, like for more complex problem, the probability for solving a problem is too much high, and in the classical computer they can try one by one probability, the one by one methods, that it take lots of time, and sometimes it not able to find it. But in the quantum computer, they find the all probability and they stuck together and keep to an method, and they apply the all method together and find a quick solution. So I think, like the quantum computer is such a different in this case, like how the we are going to solve any complex problem. So at a normal problem you can easily solve by your classical computer, but at a complex problem where probability of and lots of method, and you can say having lots of methods, so it is too much complex to deal with on a classical computer. So you can easily apply, the quantum computer can easily solve it. Okay, so qubit, the where so I forget where the qubit play an important role, and how the qubit play an important role in this understanding the quantum computer. Qubit, I said about qubit is like it is one of the role where it take a time to understand how uh, the both condition will apply, either head or tail. I will give the example of the tossing a coin. uh, Before predicting the value, before stopping the coin, we the probability of both head and tail is same as a 50% of head and 50% of tail, as usual. So I think like when we're looking toward the probability, this both are same, then qubit refer to, I think like 4 qubit. I think say this quantum computer have a 4 qubit. Yeah, 4 qubit. That means they apply 4 4 conditions. I think like 4 into 4, 16 conditions at the same time. Yeah, I think that's right. 16 conditions at the same time. That means 16 possibilities at the same time for solving. Let come to other point. Like you can trying 16 approach at the same time. Like at 1 second you try 16 approaches, and then after next time you try 16 approach. Then I think like the speed will be fast, and you can easily deal with a complex problem. So okay, so if you comparing the more qubit, that means quantum computer is a more efficient to do such a work. Okay, so I think like 4 qubit, and if I say 4 and 5 qubit quantum computer, that means your 5 qubit quantum computer is more efficient to solving a complex problem as compared from 4 qubit. Okay, so more qubit decide more efficiency. And when we're dealing with a classical computer, so uh, okay, so let's summarize the difference between both of them, because of that, that really define your in that really clarify you about what a difference between both of them. So the first one is the speed. Okay, so quantum computer is just a slow, and sorry, classical computer is a slow, and quantum computer is a fast. uh, because of that, different in approaching style. And let's come to the time. It classical computer trying each method at one by one, and it take a lots of time. And quantum computer can apply all the 16 problems, 16 approaches at the same time, so it save a time. And the efficiency is more. So time consuming classical computer much higher as compared from quantum computer. And third one is very important, is your approaching style. The first, classical computer approach in a you can say it approach in a simple way, like it approaches step by step in all the methods. But quantum computer apply all the possibilities at the same time. And classical computer give a solution. I think like classical computer give a solution exact value, like either yes or no, 0 or 1. But they given us a particular solution as a probabilistic, that how much probability of the solving, and this is the solution. So that is difference between. So I think like quantum computer is very hype over the future tech. But there were failure in the particular quantum computer, but for management issue, it take a there is complexity in their understanding of the quantum computer. And the first failure is decoherence. Decoherence refer to a small disturbance in environment can create a lose all the property of the quantum of the quantum computer, like all the atomic quantums, and disturb the atoms. Okay, so it causes a lots of, it increase the error rate. And the failure rate of the quantum computer is much higher as a you can say as compared from the classical computer. In somehow you can say classical computer is much better. But in future we develop a lots of good technology for understanding this all the stuff. So I think like this is the basic difference between both of them, like how this are different in classical and quantum computer. But there were lack of something. But in future we add similar from the our we have in the previous time, like we have a lots of technologies here. And I think like in the classical computer have a big in size, like it covered the whole over the room. But in time it's take a lots of effort to take it microchip, and after IC development and semiconductor come and they solve the issue, and they simplify the whole computer in a single desktop and single mobile phone. This is possible due to their only for microchip and semiconductor. uh, as it is, quantum computer will be also developed, and they if the quantum computer is able to uh, perform a task very efficiently, then we have a lots of opportunity, and they unlock the lots of impossible problems like immortality, like genetic decode, and all the stuff, and cryptocurrency, and increasing the security, inscription, and all the stuff. So thanks for